In this lecture, I will discuss about double sideband suppressed carrier modulation. Okay, so moving on to detail, first we should know the general expression. This is the general expression for a AM signal. So S of t is equal to Vc cos 2 pi fct plus Vcm by 2 cos 2 pi fc plus Fm into t plus Vcm by 2 cos 2 pi fc minus Fm into t. This is the carrier and this is upper sideband, this is lower sideband. Okay, so I will just modify this. The substitute Vc cos 2 pi fct. 2 pi fc I can represent as omega c. You know that angular frequency omega equal to 2 pi f. So 2 pi fc I can represent as omega c. So Vc cos omega ct plus Vcm by 2 cos 2 pi fc plus Fm into t. So it means cos 2 pi fc plus cos 2 pi Fm into that means Vcm by 2 cos 2 pi instead cos of this is not 2 pi cos of omega c plus omega m into t plus this type Vcm by 2 instead of this cos of omega c minus omega m into t. So this is the general equation. This is the carrier and this is the upper sideband, this is the lower sideband. Okay, next is double sideband suppressed carrier modulation. So we know that this is the general expression. S of t is equal to Vc cos 2 pi fct plus Vc ka m of t cos 2 pi fct. So this is the carrier, this is the sidebands. So we know that if the modulation index is 1, 66.67% of power lies in carrier and only 33.3% of power lies in sidebands. That means only 33% power is make it as useful and the 66% of power is wasted in the carrier. Okay, so the efficiency is very less. Only 33% efficiency we will get in this system. So one might think that if we suppress this carrier, suppose if we suppress this carrier, we can increase the efficiency. You know, if we suppress this carrier, we can save this 66% of power. Why? Because we suppressing this carrier, so the power which is used for this carrier we can eliminate or we can save that power. Okay, that's the method we used here in double sideband suppressed carrier. So this method is introduced in order to increase the efficiency or in order to increase the transmitted power, in order to increase the efficiency. Why? By suppressing the carrier we can eliminate the wastage of power in the carrier and the effective power which is used for transmission, which always lies in the sidebands, and we can, in that way we can increase the efficiency. So how to suppress the carrier? So the carrier is see here K is the receiver sensitivity, we take it as 1 and the carrier is completely suppressed and that means this time is 0. So what is the remaining time? Vc K is 1, Vc m of t cos 2 pi fct, Vc m of t cos 2 pi fct. This is m of t. Vc cos 2 pi fct is nothing but carrier signal and it is represented as C of t. So m of t is the message, C of t is the carrier. Multiplying carrier message you will get S of t. So here the thing is, this is the modulated signal and the modulated signal does not have any carrier component. This is the carrier component Vc cos 2 pi fct. Here we have only the sidebands, no carrier is present. Okay, now how to draw the spectrum of this DSB signal? This is the DSB-SC signal, double sideband. DSB-SC means double sideband suppressed carrier. This is the spectrum. How to draw spectrum? Vc by 2. For this term it is represented as m of f minus fc plus m of f plus fc. Okay, if this is the message, then after modulation the spectrum become, that is the spectrum of this modulated signal look like this. You know how to draw. this changes to plus fc and this changes to minus fc. This is the spectrum of original message. So this is the spectrum of modulated signal, frequency domain representation. How to draw m of f plus fc. So this times, instead of f you put it as 0, that means 0 plus fc plus fc. So at plus fc we replicate this area, and at minus fc 0 0 0 minus fc 0 minus fc, that is at minus fc. Again we have the same message, but the thing is, you look at here the carrier is suppressed. That's why I put fc as a dashed line. Why? Because with this dashed line representation, it is understood that the carrier is completely suppressed. That's why I drawn it in dotted line at fc. That means at fc is nothing but the carrier, and the carrier is suppressed here. Here also the carrier is represented by dotted line. That means it is suppressed. So we have only upper side band, lower side band. Here also upper side band, lower side band. Okay. So in order to draw this spectrum, what you have to do is you just take this expression. This is our spectrum of message. Here we know that it is replicated at f plus fc and f minus fc. Here f you take it as message frequency. Message frequency, center frequency is 0, and it is higher frequency plus some, lower frequency minus some. Okay. So what you have to do is you put this term here. That means here the frequency term is 0, so 0 plus fc plus fc. That means at plus fc you have to replicate this spectrum, and now you put here 0 0 this term here. That means 0 minus fc minus fc. So at minus fc you have to replicate this. So in this way you draw this spectrum. Same 0 plus fc, and what is the highest cutoff? This point here 0 plus fc. At this point m plus fc. Here minus m plus fc. So fc minus m. Okay, like this way. Here you put entire term here 0 minus fc. How to draw? Here 0. How to draw the signal here? You just put entire term here. First term is center point. Center point is 0. That means put this f as 0. 0 minus fc minus fc. So the new center point is minus fc. What is the new highest cutoff frequency? Minus m. Put instead of f you put, if you want to find this point, you put that point here. So minus f minus fc. That means minus fc minus f. That is the point here. Here the point is m. So you put here m minus fc. That means m minus fc. So this is the way you can replicate. And how to find out the bandwidth of modulated signal? You take any spectrum component. This is the highest frequency, this is the lowest frequency, this is the center frequency. To find out bandwidth, how to find out bandwidth? The upper cutoff frequency minus lower cutoff frequency is the bandwidth. Upper is fc plus m, lower is fc minus m. So you subtract. In order to find out the bandwidth, what you have to do, you subtract. In order to find out the bandwidth, what you have to do, you have to subtract fc plus fm minus fc plus m minus upper cut minus lower cut is fc minus m. Okay, so if this term become minus and this term become plus, so the remaining finally you will get 2 times m. Okay, that's why bandwidth is represented as 2m. And this is the spectrum. Now you need to know the power calculation and efficiency of this carrier, this SSB. This is a single tone modulation. This is considered a single tone modulation. Single tone modulation means here we use only one message signal for modulating. Okay, only one message signal is used in this modulation. Several messages can be used in modulation, but that is called a multi-tone. That means several message signal we used for modulation. Here only one message is used for modulation, so single tone modulation of AM. This is nothing but DSB-SC, double sideband suppressed carrier. S of t is VCM of t cos omega ct. Okay. And the remaining will discuss in next class.